Hello, math nerds! Time for another derivative video. Dun, dun, dun. Okay, so today we're going to talk about trig functions because, in the last video I couldn't do a few problems because I didn't know my trig derivatives is what I call those, so if you hear me say that. So when I approach this, I like to approach this more of a graphical sense because it helps me kind of make better sense of it. So I'm going to do that with you. So what we're going to do is on the sine graph, I'm going to read the instructions and follow them with you. How about that? So it says, on the following graphs, mark the x-axis with a point for all of the places where the graph has a zero slope. Because remember, we're looking for the derivative, and the derivative is all of the slopes together, the slope at each point. So I'm going to go and find, and this is going to be probably funny with this pen. If I were like a skateboarder, right, and I were on a board, where would my board be flat or have a zero slope? And I see one there, and I see one there, and I see one there, and I see one there. So the slopes of the tangent lines at all those points would be zero. So what I'm going to do is I'm going to put 0 as the y value for the derivative graph. So at this x right here, I'm going to put a 0 mark. So what I'm doing is I'm actually marking what the slopes are on the axis in red. Okay? And then I kind of I'm going to have to guesstimate just a little bit. It says now, mark a value of 1 and -1 for all x values that the given graph has a slope of 1 and -1. So we're going to get on that same board, and we're going to ride the board again, and we're going to figure out where it would have a 1 or -1 slope. So if you think about it, if you drew a tangent line right there, that would probably have a slope of 1, so I'm going to put a value of 1. So the y values that I'm putting on the red graph indicate the slope of the curve that is in black. And so notice that that's kind of 1, and then I go 0, there's 0, and then I would go negative, and then about right here would be -1. So I'm going to put a value at -1. So the red dots, let me go back and make these dots. So the red dots indicate what the y value of the red dot indicates the slope of sine at these points, okay? So positive slope, I'm going to put a positive 1. 0 slope, I'm going to put a 0 value. -1 slope, I'm going to put a value of -1. 0 slope, a value of 0. What do you think would be the slope there? It looks like positive 1 again. So I'm going to put a value of 1 on this derivative graph. So really what I'm doing is I'm finding the slope at easy to find places, and I'm putting the value of that slope as a y value, and when I get finished, I'll have a picture of the derivative graph, of the graph of all the slopes. Isn't that cool? And that's what we've been calling that general derivative. I know, it's so neat. So then I go 0 slope, this is -1 slope, so I'm going to put a value of -1. Whoops, sorry, got some little stray marks here. 0 slope, and that would be a value of 1. So if you connect this, you will see somebody you recognize. Let me see if I cannot connect them. Kind of okay. Should recognize him. Well, Lordy, if I could graph, it is kind of hard with this particular little pen. My pen just got goofy on me too. In this direction. We'll get there, right? All right, so look, guys, do you recognize him? He looks like the guy right there, doesn't he? So if you plot all the slopes on sine, you get cosine. I know, it's crazy. They are each other's derivatives, maybe. Well, at least that one is. All right, so let's see if that works for cosine. So I'm going to do the same approach. 0 slope, 0 value. -1 slope, -1 value. Zero slope on this graph means a zero value. Positive 1 slope means a positive 1 value. Zero slope means a zero value. Negative 1 slope means a negative value. Zero slope means a zero value on the derivative. Remember, slope of a tangent line means derivative. Positive 1, here we go, about right there, and goes to 0 again. Let's connect these points and see if we recognize this guy. Meow. I'm thinking it's going to be sine, don't y'all? I mean, if the derivative of sine was cosine, I mean, this has got to be the other guy, right? And then I'm thinking, well, that's not quite sine. If that sine start at 0 and go up first and do that, so this is the negative of sine. Isn't that crazy? It's the negative of sine. So the derivative of sine is really cosine. It really is. And the derivative of cosine doesn't quite, I mean, it is sine, but it's the negative of it because it starts going down first instead of going up first. Ain't that nuts? I know, right? So now we're going to find the derivative of all the other trig functions by using our relationship. So let's go do that. I have an empty page to write on. So the first guy we're going to tackle is tangent. And how are we going to do that? All we know is sine and cosine, right? But I know that tangent is equal to sine x over cosine x. And so I'm going to use that quotient. Oh, did I say quotient? I did. So I've got to use the quotient rule to do this. So, and you know what, I need to tell you I'm taking the derivative. So let's do that d dx thing. So the derivative of tangent, which is the derivative of this, is going to be, I'm taking the derivative, is low d high. So what's the derivative of sine? We just said that was cosine. Low d high minus high d low. The derivative of cosine wasn't exactly sine, it was negative sine. Over low squared. And I know I have some of you who don't like that, so let's do this in good stuff. And I'll do it in blue so you can kind of see that. If you like notation, I can do notation. So g of x times f prime of x minus low d high, bottom derivative of the top, minus top derivative of the bottom over the bottom square. Just reminding you of all that. Okay, so that is the quotient rule because we wrote tangent as a quotient of two things that we do know the derivative of. Okay, well, let's see what I got. I'm looking back and what is that? So I see that cosine times cosine is cosine squared, right? And I see minus times minus, which is plus. Oh, I just see something I absolutely just fell in love with right there. Ooh, woo! Let's get us a little line there. There we go. And then cosine squared. We'll put squared there. Now, here's the cool thing. What is cosine squared plus sine squared? Pythagorean theorem, right? It is 1. Yay! And what is 1 over cosine squared? That is secant squared. Isn't that beautiful? So, ladies and gentlemen, the derivative of tangent x is secant squared. And you'll probably won't ever have to prove this again, but I wanted you to kind of know where it came from. People would just expect you to know the derivative of tangent is secant squared. And one of the ways to remember it, if you know anything about your Pythagorean identities, tangent and secant are in the same identity, so that might help you kind of go, oh, it's going to be that. I don't know. It helps me. That's how I remember it. All right. So let's go do one more of these, and let's go do secant. Oh, I gotta say of secant, don't I? Sorry. So again, I have to write that as 1 over cosine x. And I'm going to have to do a quotient rule of this because the other way that we would have to do this we haven't talked about yet. So I kind of have to do this. So I'm going to do low, d high. Look at that, it went away, right? Derivative top minus high, d low, because cosine is negative sign, remember that's weird, over low squared. So that's that. I don't like that. There we go. So the derivative is that. So that makes that go away. And that makes us have positive sine over cosine of x squared. Now, there's a reason why I'm writing it like this. So we normally don't see the derivative like that. What people normally do to get a kind of a cooler answer is they rewrite cosine as cosine squared, as cosine over cosine, and they split these up so they get sine over cosine and 1 over cosine. And so that means that the derivative of secant x is sine over cosine is tangent x, 1 over cosine is secant x. So it's really cool that secant has itself and its buddy that kind of within the other derivative, they're together. So derivative of secant is secant tangent. Or tangent secant, doesn't matter, that's commutative. But that is the derivative. And that's kind of how you do that. To find the derivative of cotangent and cosecant, you would do the same process that I did for these two, and you're welcome to do that. All right, so let's recap. The derivative of sine is cosine. We saw that. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of secant is secant tangent. He is in his own derivative, and his buddy tangent's hanging out with him too. That's how I remember that. I know it's strange. So I just kind of fill in the blanks here for you because you're really just going to have to know these and use these. But what's really cool is that, you know, if secant squared is the derivative of tangent, then cosecant squared is the derivative of cotangent. But like cosine had a negative, so does cotangent. And if the derivative of secant is secant tan, then the derivative of cosecant is cosecant x cotangent x, but all the c's are negative. So it's kind of like if you know these and you know that cosine is negative, you can kind of fill in those two because they are very similar to each other. The cos, if you know these, the cos are just the co of that. Are you with me? And they're negative because the derivative of all C trig functions are negative. Okay, so now we're going to use that. You ready? Here we go. So in number 1, you have a trig function and a normal function added. So you're going to take the derivative of this trig function and say plus the derivative of this normal function. That's all you do. All right, so here I go. So the derivative of 2 times a function, if you know the derivative, is 2 times the derivative of cosine is negative sine, because sine and cosine are each other's derivatives and all the c's are negative. And the derivative of 7x is just 7. This would probably read negative 2 sine x plus 7 because I pulled that negative out front. And number 2, to find the derivative of sine is cosine, minus the derivative of tangent is secant squared. So those are just, you got to know them and do them. Okay? Number 3, however, is going to be different because these two things are being multiplied. So we must do the product rule. In the product rule, we must do 1d2 plus 2d1, or f of x times g prime of x plus g of x times, I don't think you're going to be able to say that, f prime of x. Sorry, I think I ran off the page. So here's number 3, g prime of x, because I'm getting large in writing. So when it says f of x, or 1, and I call that 1 and that 2, that means write it down. Then take the derivative of the second function, and it is itself and its buddy. And how do I know it's positive? Because it doesn't start with a C, it starts with an S. That's how I remember that every time. Product plus the second function, write it down, times the derivative of the first, 1/2 x to the negative 1/2. Okay, do I need to stop and show you that again? You know, that's really x to the 1/2. Take your power down, subtract, right? That's how we get that every time. And for those of you who like a pattern and want to use a pattern that's kind of cute, the derivative, if you rewrite this, then what that would be is the 2 would be on the bottom, but so would the square root, because that's a negative square root. So a lot of times you will see the derivative of root x written like this. So if you ever see that, and sometimes I'll do that, and so I don't really write this form normally. So if you see me do that, I just wanted to explain it. That's what I'm doing. I'm just going from there to there. I like this look. I like this pattern, and I use it a lot. Okay, well that was it. You know what? I think we should go back to the video problems from yesterday, and I'm still in the same little program, so I can do that. So I'm going back to the ones we skipped. See, I'm going back in time. And let's do 10, 11, and 12, because we can now. Ha ha! Hee-hee! All right, so if I'm doing number 10, I have a quotient. I must do the quotient rule. And so we're going to draw the line, ready, right, to get ready for that. So the quotient rule, you always start down low. And that means write it down. D high means take the derivative of the top function. This is the high function, this is the low function, right? And so low, D high. So 1/x is the derivative of natural log. Minus low D high minus high D low. Now I have to know the derivative of cosecant. Because it's a C, it's negative cosecant and its buddy. How I remember that. Low D high minus high D low over low. So the bottom function squared. And I am going to clean this up just a little bit, just because I want to, and I can. That minus will make a plus. I'm not really going to clean up much. Can't do that very much, can I? No, I cannot. Yeah, that's all I can do. Sorry about that. Probably more trouble than it was worth. So once you know all your derivatives of e to the x, natural log, and your trig functions, then you have to figure out how are they related to the other function. For example, in number 11, this is multiplied, so we have to do the product rule. And the product rule says 1, write the first one down, d2, derivative of the second is natural log, product plus 2, d1. And this is where you've got to know that the derivative of cotangent is negative cosecant squared. So you got to kind of study those and get those down. The way I remember that is I know tangent is secant squared, so cotangent is cosecant squared, but it starts with a C, so it's negative. And that's my answer. I'm leaving it. Done. All right, so let's do the derivative of 12 real fast. It's a what? It's a division. It's a quotient rule. That's right. Quotient rule. So low D, come on, pen. Low D high minus high D low Because remember the derivative of e to the x itself over low. That's f, and we'll try to do it in symbols too. I always try to do that because I have people who don't like my lady half step. Sorry, I know, right? Oh, so it's trying. Oh, I don't want to call it F, do I? Call it H and G, maybe. So if that's H, then it's. Oh, I didn't do that well either. Sorry. So that's H of x times G prime of x, bottom derivative of the top minus top derivative of the bottom. You know how many times I've said that phrase? I know, right? Over the bottom square. I'm going to sing my song again, though. Low D high minus high D low over low. There you go. So that's the end of trig functions combined with everything else you've done. Hope you've had fun. The next one will be the chain rule. See you then. Bye-bye.